Let's remind ourselves here today how to graph different kinds of rational functions. Now, they're very fun, obviously, because they involve fractions. Think ratio. A rational function is something that involves a fraction with a variable in the denominator. If there's no variable in the denominator, then it would not be rational. It has to have a variable in the denominator. Like our first example. So let's say we wanted to graph this rational function. Well, if it doesn't already come pre-factored, definitely a good thing to do because the factors will help us get the intercepts, the asymptotes, and the wholes that we need. So let's go ahead and do that. We'll factor the numerator, which would not only be able to factor out the 3, but then we get a difference of squares, and then we'll factor that denominator as well. Now I notice they have a common factor there. Now a common factor creates a whole. So in this case, the whole is at 3. Now we can get the y-coordinate as well. So the thing to remember, excuse me, is if we want the y-coordinate, then what we'll do is we will cancel out those factors and then plug in the whole's location, 3, into the remaining expression. Hence we got 3, and then 3 plus 3 was 6, and 3 plus 4 is 7. So that gave me 18/7, and that is the y-coordinate of our whole, which when we get to graphing will be an open circle. Because there's not anything there. It would be a 0 over 0 or undefined value, since it's a common factor. Alright, so that takes care of our wholes. So now let's move on to the intercepts. Well, an x-intercept is when our expression is equal to 0. A fraction is 0 if the numerator is 0. So it can't be an x-intercept at positive 3 because that was a whole. But there is still a factor in the numerator, x plus 3, which would give us the x-intercept of negative 3, 0. Now intercepts are points, so we really should be labeling them as points, not just as a number, or an x equals negative 3. That would be bad form. Now there is another kind of intercept. That's the y-intercept. So the y-intercept is going to be an x equals 0 statement. So what we'll do is we'll plug in 0. Now when I plug in 0, I get 3 times 3 over 4, or 9/4. So my y-intercept would be 0, 9/4. And that takes care of that as well. So that gets us to now the asymptotes. So for asymptotes, we've got vertical and then non-vertical. Now a vertical asymptote comes from a number that is not 0 divided by 0. For example, 1 over 0, 3 over 0, 9 over 0, negative 1 over 0. All those are undefined. So in this case, the denominator would be 0 when we have negative 4, or of course 3. But remember, 3 is a whole. So the vertical asymptote would be x equals negative 4. Now notice this is the first thing we're not writing as a point because asymptotes are lines. So it would be an x equals negative 4 because it's a vertical line. Now there are such things as non-vertical asymptotes. Those come from looking at the coefficients of the highest power. Well, the highest power you see circled there is the square. We had 3x squared in the numerator, x squared in the denominator as our leading coefficients. 3 to 1 would be the horizontal asymptote. That would be the end behavior, or the limit as you approach infinity if you're familiar with limits. Now, if we're being super duper proper, horizontal lines, I know you're probably thinking Algebra 1 was a y equals statement, but notice our function name was f of x, so we just call it f of x equals 3. Excuse me again. So now we've got enough information, we're going to actually get the graph. So let me get my axes going here. I've got them labeled x and f of x instead of y. And we're going to plot the points first, and the asymptotes as well. So here are my asymptotes. They're drawn as dashed lines, and then here come my points, which are the x and the y-intercept. Now the whole will be drawn as an open circle. Always draw them as open circles. There's that location 3 and then approximately 18/7. Now, when we want to draw the rational function, if there are points already, which there are, you can just connect them and use the asymptotes as end behavior lines. So the end of our section should be heading to those asymptotes. So I'm going to connect those dots and head towards the asymptotes. Now that's the right side of my function, but there is a left side to my rational function. I could plug in negative 5, I could plug in negative 10. Now the question is, where should I put it? Now could I create a table of values? Absolutely, but I don't have to, because remember there was only one x-intercept. That was at negative 3. There are no other x-intercepts because there are no other factors in the numerator. So that means that my function, since there are no x-intercepts below negative 4, has to be in that upper left-hand quadrant. So that concludes my graph. Again, I could use a table of values, but I did not have to in this case. Now let's take a look at another example. Let's say I wanted to graph this rational function. Notice this is a different scenario. We've got the power of the numerator is greater than that of the denominator, so we'll have some different quirks. Well, we need the usual stuff. We need to find all intercepts it has, all asymptotes of any kind, as well as any holes it may have. Best place to start, factor that bad boy. So notice I've got the factors in the numerator, excuse me, not canceling with anything in the denominator, so there are no holes. Always a good place to start with those holes, because once you know your holes, then everything else can be found without accidentally thinking it was an intercept when in reality it was a hole. So anywho, holes are done. There weren't any. So now we'll move on. So we have one thing in the denominator. If things in the denominator create vertical asymptotes, so it'd be x equals 3. Now, our non-vertical asymptote, remember we said that came from our leading coefficients ratio. Well, the leading coefficient would be 1x squared over, oh, wait a second, that's an x. You know what that means? That means I have 1x squared over 0x squared. That's undefined. That's a problem. Not really, but it means I have to do something different than last time. That means that I'm going to find this non-vertical asymptote. It's going to be a slant asymptote. And the way I'm going to do it is I'm going to divide. So I'm going to divide. Synthetic division is the easiest way. I'm going to divide that numerator, 1x squared minus 2x plus 1, by x minus 3. Remember you put the 0 in the box of your synthetic division. I ran that synthetic division, and I got the remainder of 4. Now, since a asymptote is an end behavior, that remainder is going to end up being ignored, because since that remainder would have been represented as 4 over the quantity x minus 3, as I head to infinity, I'd be heading to 4 over infinity minus 3. That's going to 0. So as I get close to the ends, that remainder is not going to be important. What will be important is that 1x plus 1. That line is what our ends are heading towards as we go to x of infinity and x of negative infinity. So that's going to be our non-vertical asymptote. So that's a non-vertical asymptote. We'll end up drawing it just like a vertical asymptote as a dashed line. But before we get to that graph, let's finish out getting our intercepts. So x-intercept, super friendly. That was from the factors in the numerator. There's only one. It's repeated, but it's just x minus 1. So the x-intercept would be 1, 0. Now the y-intercept. Well, the y-intercept comes from plugging in 0. So when I plug in 0, I really am just going to be left with those constants at the back. So I can either plug it in or identify the ratio of the constants. It's going to give me the same thing. The y-intercept is 0, negative 1/3. Now I can do the fun part. I can graph it. So I've labeled my axes, labeled my intervals as going by 1s. Then I'm going to draw those asymptotes. So I've got x equals 3. Then I'm going to draw that lovely little line, x plus 1, also as a dashed line. And then I'm going to plot my points. I have the x-intercept of 1, 0, and I've got the y-intercept of 0, negative 1/3. Now we can play the connect the dot game. Now here's the thing. I know it's supposed to head to the asymptotes, but as it stands, unless I know a little bit about math, I don't really totally know whether it's supposed to go up or down to that x equals 3 line. So if you're uncertain, you can always do a table of values. So let's say I did that. Let's say I plugged in 2. I would have gotten negative 1. So that means that I would have had to go down. And then I would continue down because I can't create an x-intercept that doesn't exist. So once I start down, I have to keep going down. I already have a dot on the other side, so I know for sure it's going to connect to that dot, not create any new x-intercepts, and head towards the slant asymptote, its first barrier or end behavior line. Now, I have the left side complete. There is nothing in the upper left-hand portion. The left is complete. The picture is in the lower left. There cannot be anything in the upper left, or else it wouldn't be a function. But I have not yet identified where on the right it is. It will either be in the upper right or the lower right. Now, I could use a table of values, or I could just realize there are no x-intercepts. So it can't be in the lower right, or else it would have to cross the x-axis. So that means it has to be up in the upper quadrant. So if I, excuse me, if I use a table of values, I certainly could. I could use as many or as few as I need, but in this case, other than possibly needing that 2, negative 1, any others would have been extra work because I could have told just based off of what x-intercepts it did not have. All right, let's look at one last example here. Excuse me. So in this last example, we have the powers again. They're different. By powers, I mean the degree, or highest power you see on the numerator and denominator, but they're in the opposite ratio. This time the highest power is in the denominator. All right, so that's going to complete all of the different things that we need to know about rational functions. So let's get to it. Same old, need the intercepts, need the asymptotes, need the holes if there are any, and the way we find them is by factoring. So after a little factor fun, I can see that, oh, there is a hole. So I've got a hole. Remember that we can cancel out that hole and then plug in 0 into what's left. That would end up giving us -1. Ta-da! We have our hole. It'll end up being an open circle. Now I need my x-intercept. That comes from the factor in the numerator. That remains, and that would be 1, 0. Y-intercept? Well, I'd plug in 0. Interesting things happen, though. I get 0 of 0. That's undefined. When that happens, that means there is no y-intercept. Remember, it's a hole. So there's no y-intercept. And now on to the asymptotes. So I have only one factor left in the denominator. But the problem is it can't factor over the reals. The only zeros that it has are plus or minus I. And I doesn't show up in the xy plane. So there are no vertical asymptotes. That leads us to non-vertical asymptotes. Well, this one's going to be horizontal. Because again, think of the degree, the leading coefficients. Right now, we might initially think, oh, it's 1. But notice those two circled items. They're not the same power. So up top we have 0x cubed divided by 1x cubed. 0 over 1 is 0. So we have a horizontal asymptote at f of x equals 0. Alright, so let's do the graph. So we'll label the axes, we'll label the intervals, and then we'll start putting in those asymptotes as dashed lines. But there's only one of them. I also put the hole in there. There's just one of those. Then I also have that x-intercept. Wow. How in the world am I supposed to get this graph? This is crazy. Well, again, all else fails, table of values. Now, as to the function right now, I can actually tell for sure what the left side is doing because I know that there are no other x-intercepts and it's supposed to head towards that asymptote. So from that hole on the left, it's going to start having to head towards that asymptote. There's no place else for it to go. Again, I could use the table of values if I needed to. And I know it's going to go from the hole to that x-intercept. But then maybe from there, I'm not sure what it does. Now again, you know a little bit more about math. Maybe you do. But let's say I didn't. I could use a table of values. I know it's going to connect to the x-intercept. Then I could just test a bunch of values, and oh snap, I realize that after a slight increase, I know you don't see that increase necessarily, but there would be some sort of maximum between 2 and 3. Hence it has the same y coordinates, go a little above, and then come back down to 1/5. But then just gets smaller and smaller and smaller because it's heading towards that asymptote of a height of 0. So there we have it. We can use the table of values for as much as we need. Feel free to use as many points or as few points as necessary. And just like that, we've completed our graph. So hopefully that helps you out with reviewing some rational functions, and perhaps I shall see you again soon.